Good day everyone! Welcome to That Friendly Writer's Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll finally learn the two-tailed hypothesis testing as an easier replacement for the one-tailed test. Alright, let's get started. In a hypothesis test, we should understand that the stricter the test is, the more valid conclusions we may have. Suppose we have a statistic of 1.78, and under a one-tailed 95% confidence level, the critical value is 1.645. This means we are able to reject the null hypothesis under this critical value. Because we have a low critical value, we have the possibility of increasing the risk of a type 1 error or a false positive. But what happens if we use a two-tailed 95% confidence level? The critical value becomes a higher 1.96. This means our statistic of 1.78 does not yet pass the critical. This is the beauty of a two-tailed test. It becomes much stricter as compared to the one-tailed. A higher critical value means we do not easily reject the null hypothesis, thus reducing the risk of a false positive. Although it does increase the chance of the type 2, but we'll handle this at a different topic. In addition, a one-tailed test considers the direction of the statistic. We have to be careful of the words less than, greater than, and their variants, such as shorter, above, higher, decrease, and the like. We need to use the proper symbols for a one-tailed test. However, in a one-tailed test, this no longer has a specified direction. That's why a two-tailed test is also called as a non-directional test. This becomes less confusing because we no longer look at the direction. We just consider if the results are not equal or different to what we are trying to compare. Let's have an example. Did you know that healthy cats have a standard average heart rate of 190 beats per minute? This is the standard. However, Julie has a problem with her cat. For the past 6 days, her cat seems to be down due to the following heartbeats. She is now tempted to force medication her cat if she finds evidence that her cat has a really different heart rate than usual. So, let's help Julie by using a one-sample t-test. First, let's give the standard and then calculate the sample statistics. Pause this video to try solving these first. Alright. We are now ready to fill out the statistical table for hypothesis testing. We need first the alternative and the null hypotheses. In a two-tailed test, the alternative hypothesis always uses the not equal symbol because there is no direction involved. This makes the two-tailed test simpler. The null hypothesis, as always, uses the equal symbol because it is a statement of no change or no effect. We place the population mean mu as the standard. Next is the computed sample mean x bar. We use the one-sample t-test formula and compute for the statistic of negative 0.89. We use the t-table to give 2.57. Remember, alpha is 0.05. We now use two-tailed, and the degrees of freedom is 5. A computer generates the p-value for us. In this case, the p-value is 0.46 or 46%. Our decision is not to reject the null hypothesis because 0.89 did not exceed 2.57. Also, a p-value of 46% is not an extreme value. It is a common phenomenon, assuming the null hypothesis is true. Hence, the sample average heart rate of Julie's cat is not significantly different from the standard. So, should Julie force medicate her cat? The answer is no, because nothing seems to be wrong with the heart rate of the cat. Maybe the cat is not really ill. It must be having bad days. Or if it is truly ill, then its heart rate is not the problem. Maybe it's something else. Or maybe the cat is pregnant. Again, the statistic only compares, but it is up to the researcher to give meaning to the results. Thus, to summarize, the beauty of the two-tailed test lies in its strictness and simplicity, as compared to the one-tailed version. Therefore, we don't need to use the one-tailed test, unless it is absolutely necessary. In most cases, the two-tailed test should already be our default choice. There we go, the two-tailed hypothesis testing. For your practice, here is a sample problem. Read first the standard as seen in front. The sample data is now presented to you. You may pause the video for more time. Now, let's fill out the statistical table. First, let's give the alternative and the null hypotheses. I will now give the answer in 3, 2, 1. Here are the answers. Next, let's give the standard and the sample statistics. I will now give the answers in 3, 2, 1. Here are the answers. Let's fill out the table. I will now give the answers in 3, 2, 1. Here are the answers. Now, which hypothesis did you choose, the null or the alternative? What do the results imply? I will now give the answers in 3, 2, 1. Here are the answers. Were you able to give the correct values inside the table? Were you able to interpret the results? You may watch this video a few more times to understand this more. Alright, this concludes our video for today. Hope you learned something new and have a friendly day.